Hello, everyone, and thanks for joining us today. My name is Alexandra, and I will be your webinar host, which means I will be handling all of your Q&A. During the presentation, we have enabled the questions panel, which you should see on the bottom right-hand corner of your screen. You may need to push the plus sign to expand the panel. This session is being recorded and will be made available for all attendees should you care to listen to it again or share it with colleagues. Now, I'd like to introduce our speaker for today, Mark Henry, who will present how to quickly diagram and document your enterprise network. Go ahead, Mark.
Thank you, Alex. Hello and welcome, everyone. My name is Mark Henry. I'm a senior engineer with Opmantic's North American office located in Charlotte, North Carolina. As Alex said, today we're going to talk about how to diagram and document your enterprise network. So just a little bit of housekeeping for everyone. Everyone's on mute during the presentation. After the presentation, when we get done, I'll take everyone off mute. We'll also stop the recording at that point, and you can, bring up any questions you have. You can also type any questions you have into the chat window, and Alex will bring them to my attention, and we can try to address them during the discussion if you want to get that route. All right. So topics for today, we've got kind of four big picture items that we really want to try to touch on. So we're going to talk about the importance of maintaining accurate network diagrams. We're going to talk about how to logically organize and partition your network diagrams. We're going to talk about creating and updating network diagrams, including device and interface information. And finally, we're going to talk about leveraging live diagrams for performance and fault management. Obviously, coming from our position here at Opmantic, as a provider of network monitoring solutions, all of these pieces are going to be kind of focused on our solution sets. However, these concepts can really apply to any network monitoring solution that you have out there. So let's talk about why you might want to maintain accurate network diagrams. And this is really it's kind of my top 5. And I actually compiled these just by simply Googling maintaining network diagrams. And you can find hundreds of blog articles and websites, some of them written by network monitoring companies like Opmantic, other ones written by MSPs or just network scientists. Really, my top 5 pieces, having owned and operated managed service providers myself, coming from several enterprise-sized companies and running their networking departments, and now working with Opmantic and talking to literally dozens of enterprise service provider sized prospects every week. Really what it boils down, that I'm hearing anyway, is that you really need something detailed and accurate to help support all of your system audits. We're talking about like a PCI DSS, the NERC audits, the SAS 70, SOC 1, SOC 2 audits. All of those audit platforms require you to have some kind of a architecture plan, something that's laid out that details, at least if nothing else, the backbone or core of your network. What are your gateways? What are your interfaces? Where are your DMZs? Especially when it comes to PCI, what's your PCI DSS DMZ areas? So having an accurate network diagram ready to go on a moment's notice helps you deal with those audits very, very quickly. The second level is really how to be able to quickly understand the impact of an unplanned outage. And so, for example, when your ISP calls and says, hey, we're taking down 2 of your circuits, you're going to be losing this location, your point-to-point MPLS network is going to be going down, to be able to understand how does that impact, where can you reroute traffic through. Having that overall network diagram handy, of course, addresses that very quickly. The third level that I often run into is when especially senior level management comes in towards the end of the year and says, hey, we need to make budgeting plans for next year. We need to understand where we're having capacity issues. Now, obviously, that can run into things like performance and fault monitoring, trending and analysis. But if you have an accurate network diagram to begin with, then you can start planning where our circuits overloaded. More people are being added onto this one geographic location. We might want to add a backup circuit. We might want to beef up our routers that are in that location. We might want to add additional connectivity over there. We have more users that are going to be using certain services, servers, storage, etc. So keeping track of where your loads are, where your bandwidth is being used, where your bottlenecks are as well, the age of your equipment, end of life, end of service, those types of things all help drive capacity planning and, of course, budgetary considerations. The fourth piece that comes to mind, and this is one that's actually kind of near and dear to my heart, having gone through a couple of different hurricanes, having to help companies rebuild following those types of catastrophic events. Having accurate network diagrams available can help tremendously in just being able to go back and rebuild the overall architecture and logic of that network, whether it's at an offsite location, being needing to mimic certain types of signals or circuits or layouts, multi-tiered architecture for applications, etc. So having those accurate network diagrams can really save you time in trying to rebuild after a DNR event. And finally, the fifth piece here, again, these are just my top 5, yours might differ slightly, is frankly, it's easier to maintain your network diagrams than it is to recreate them every 3 to 5 years. I was working with a client just last week who has some rather old network diagrams that they were using with an older performance monitoring tool that they were replacing with Augmentic solution. And they wanted to reuse those network diagrams. The problem is that they were anywhere from 3 to 5 years old. They frankly didn't represent the current architecture at all, and as a result, they were both misleading and they were problematic. They didn't have the original diagrams, which were built in Visio. All they had were the output JPEGs that had been created, and they didn't want to have to rebuild the older Visio diagrams. So in coming in, we were able to help them understand that they could rebuild everything they had directly in Augmentic's solutions using topology mapping, and they didn't have to actually rely on those background images. But if they wanted to have those background images, if they wanted to have additional annotations or documentation, that's perfectly fine. Our solutions support those as well, but you'd want to have those background images be up to date. You'd want them to be accurate, and you'd want them to be referenceable, so that you could come back and that they would always provide value to the team, and the team wouldn't be sent down wrong paths during troubleshooting exercises, etc. I've seen thousands of network diagrams over the years, literally thousands, and they can be network diagrams that are overly granular to the point where it's literally a diagram with one router on it and just a half dozen lines leading off the router representing the links from that one device out to the rest of the network. To the other end of the spectrum, where you have thousands or even tens of thousands of diagrams, and you're scrolling and zooming in, zooming out, and panning and trying to find the part of the network that you're on and where are you, and the diagram is massive. It's unwieldy. It leads to very large file sizes, which lead to file corruption, which lead to all kinds of recovery issues. So what we try to advocate here at Augmentech, and again, this is irregardless whether you're using our device discovery and auditing solutions or our performance and fault management tools, whether you're using our tools or anyone else's, we really try to advocate a multi-level abstraction approach. And this is something that we also advocate in our single pane of glass training webinars as well, where you look at anywhere between abstracting from 3 to 4 levels. You want to have a very, very high or abstract map, something which may be large topological, so very large groups, might be geographic in nature, if that makes more sense to you. You want some kind of a middle level of detail, pardon me, which may be more of a regional or service level. We kind of call that a primary key. And so the concept at that middle tier is it might be physical locations, a city, a building, floor, a rack, might be a logical location, a LAN or a subnet, or that middle level might break down roles. So you might have a map for your core network, your edge network, your distribution network, etc. And then finally, at the detail level, it'd be more of the device level. So you'd have information on configuration detail, fault information, and device level information down at that point. Again, these are just recommendations. The concept being, again, is that you want to be able to provide abstraction. So give someone an overall view of the entire network or a large piece of the network, and then have them be able to drill down from that top level. And if you're doing this in a tool like Visio, rather than the pieces that we're going to demo here in a bit, if you're doing this in something like Visio, you just take that same approach. You create a very high-end diagram of the network, just some big blocky chunks of functionality, and then each of those pieces then drill down into a separate diagram with more and more detail as you go further and further into it. So it's very much shaped like a pyramid. This one just happens to be a pyramid on its side, but it would be very much shaped like a pyramid, starting at the very top end and moving down and having more levels of detail available to you horizontally. Sorry about that. So we're going to be taking a look at two different products today, two different Augmantic solutions today that'll really lead you to be able to take care of this network diagramming for you. So the first one that we're going to take a look at is going to be Open Audit, which is Augmantic's device discovery and auditing solution. Open Audit comes in a couple of different flavors, everything from a free and open source community edition to a professional edition, which is really designed for small and medium-sized businesses, and then also an enterprise edition, which is focused more on enterprise class customer service providers, managed service providers. And the big key for the enterprise edition is that it can scale horizontally as well as vertically. The second piece that we're going to look at is we're going to take a look at OP Charts, which is our high-end dashboarding tool. And we're specifically going to focus in on topology and geographic mapping with OP Charts. And the reason we're looking at these pieces is understanding, depending on what your budget is, your timeline is, and what kind of challenges you're looking to address, each of these tools can come at kind of the concept of network diagramming, but also the concept of documenting your network from a couple of different directions. They do work with each other very, very well. In fact, we'll talk a bit about a couple of different workflows that can be done with Open Audit and OP Charts. So we're just going to touch on OP Chart, or Open Audit rather, briefly, and then I'm going to switch over from this PowerPoint presentation to Open Audit, and we'll take a look at a couple of different ways to kind of keep track of what's on your network. So the first key thing to understand is the concept of what Open Audit is. So Open Audit is all about device discovery and auditing. It's the concept that you can spin up an Open Audit server, whether it's on Windows or Linux, point it at your domain controllers, or give it a series of subnets, and Open Audit will go out across your network and it will find everything that's on an IP address. It will audit it. Doesn't matter the operating system, doesn't matter what kind of device it is. Open Audit will identify it all. So router, switches, hubs, firewalls, load balancers. Doesn't matter whether it's a piece of steel or whether it's software defined. It'll handle your AIX, ESXi servers. It'll handle your all of your Windows machines, whether it's Windows 98 all the way forward, Windows NT 2000 all the way to the latest server releases, all of your different releases of Linux, of Unix, Red Hat as well, Sun Solaris, OS X as well. So it'll take care of all those pieces. It'll even find VoIP phones, heating and air conditioning systems, etc. So Open Audit goes out, finds your devices, audits those devices, understands what the operating system is, everything about the hardware profiles that are there, and we'll take a quick look at those. And then it also gets a list of all of your software that's installed on those devices on top of all that. So we're going to switch over now. Take a quick look at Open Audit. So this is the main Open Audit dashboard. So from here, I'm just going to drill into one of the many reports that are available. So this happens to be the hardware device report. From here, I can search quickly in the top right-hand corner. I'm just going to search for Windows machines, and I'm going to open this one Windows 2008 machine called Manny. So you can see that we already have some basic documentation available to us. So for example, we have fields for the operating system family, the type of device, the description of the device, the manufacturer. In this case, it happens to be a VM. So we have all of that data available to us. We also have storage fields for additional details, so you can get information like form factors. So is it a desktop machine? Is it a mini box? In this case, it's a virtual machine. What's its form factor? But you can also get in things like the DNS domain, fully qualified domain name, its function if you want to keep track of that, etc. You can keep track of the VM host, VMware group as well. Now, in this case, we're not auditing the host machine for this VM. If we were, that would be automatically filled in for us, and the host machine would also have a list of all of the child machines for it. So when it comes to things like documentation, it's not just the form factor in the machine, it's not just the operating system of the machine, it's not even the date of acquisition, right? It's things like, what are my asset numbers? Who's the vendor that provided the machines? What's the PO number? What's the purchase date? Warranty, do I have a lease? Do I have a PO number? Now, some engineers look at that kind of information and say, well, that's really purchasing. That's not really network diagramming. I understand that contention. The line can be blurred depending on who procures the machine. Is that under the IT department? Is that under the purchasing department? Who owns that data? But making a product like this available to consumers or users in all those different departments and allowing them to then use that information can really help you step your game up. So in addition to those kinds of base level fields, we also maintain fields for location and owner. So for example, you'll see that we have the actual physical location here. So we have a defined location called the North American Support Center. We have owners for that. We even break this down into specific floors, suites, room numbers, rack positions, and you can do, how is this connected together, right? What's the switch that this is connected to? What's the switch port? How about my patch panel? Is there a wall port that this goes into? All of this type of information, again, is all about the physical interconnectedness of this device to the rest of the network. Right? Where is it located? Who manages it? Who owns it? Who's responsible for it? How much does it cost? Where is it located? In addition to these pieces, of course, we also keep track of all your networking information. So irregardless of how many networking cards you have here, we'll pull back all that information. We'll tell you the IP address, the net mask, the CIDR, where it's connected to. Now, again, this happens to be a VM. If this was actually a piece of iron, or let's say a router, you'll see much more detailed information. You'll even be able to see where that terminates to. Where does it go to? What's the MAC address of the device it connects? Couple more quick pieces here. So even though Open Audit has a ton of rich information built into it and the ability to store a lot of data, it always comes down to there needing to be some additional custom fields, right? So with Open Audit, you can define custom fields. You can define whether they're text boxes, list boxes, etc., date fields. So you can see here we've defined a barcode number field, and this can be actually printed out as a barcode if you want to. We've also defined a field for end of life and made that a text field. We have a field here called fruit, and so we can keep track of what fruit is related to this. And one of the clients we were talking to the other day identifies regions of their buildings with grid locations. And so they wanted to be able to have a field for grids, and so we just threw this in as an example. Again, you can create as many custom fields as you want with Open Audit and keep track of these pieces. Let me show you an example very quickly of a router. Again, I'm just going to do a quick search. In this case, I'm searching through the name column. Much of the same data that you saw for the Windows 2008. This one will be a little different though when you look at the networking information. So you'll see with the networking information, you get your MAC address, your connection ID, your description, if alias, your type, operator status, admin status, and the reported speed. Depending on the device that you're connecting to, you may get its availability status and the days since that interface was last changed. So you will get that kind of connectivity information, and you also get the remote MAC address for each of those ports. So what's the device that it's connected to? Where does it terminate? So a lot of this information, again, from a DNR standpoint, where do my devices go? Where are they connected? What kind of device is it? Who's the manufacturer? What's the warranty on it? If you need to reorder those devices because you've had a DNR situation, having your purchase order, your invoice, your warranty, your lease information, all of that available can be absolutely invaluable to your IT management or to your procurement department if they have to start making insurance claims or if they need to start ordering equipment and replacing equipment in a DNR situation. So again, that was Open Audit Enterprise. From here, of course, we ship with about 45 different reports built in to Open Audit to help you report on everything across the network. So when you start looking at things like networking, consumed IP addresses, interfaces used or available, your DNS domains, your Active Directory OUs, all of your AD controllers, your databases, your websites, server types, all of your installed software, your user accounts. So all of this is available to you, and then on top of that, of course, you can also create your own custom queries and reports on the fly to report on pretty much anything you want that's in the database. All right, so next, let's step up our game a bit. So where Open Audit gives us the ability to create some really good kind of relative information across your network, very, very detailed reports about your equipment, your hardware, your devices. OP Charts helps you step up your game by giving you visualization about the information that you have. So where you get great tabular kind of Excel style spreadsheets from Open Audit, OP Charts gives you the availability to do things like topology and geographic mapping. So not just physically how is my equipment wired together, where is it located, what floor, what room, what rack, but logically, how does my equipment interconnect? How does it work together? And then geographically, where is all my equipment located? So from a physical standpoint, where is it physically within the world? And then be able to kind of map that stuff out and give you a visualization of what's happening. In addition to that visualization of topology and geographic mapping is the concept that OP Charts is tied in directly with NMIS, which is Opmantic's open source performance and fault management system. And so what that additionally gives you is not just the fact that the equipment's connected together, but what is its current health and condition. So again, we're going to come back here. So let's take a look at the product. So OP Charts, from a base standpoint, provides you with just a breakdown view, a full list of all of the devices across your network. And it is scalable. So an individual server can support, depending on the number of interfaces, anywhere from 3,000 to 5,000 devices on an individual server. Those servers can be virtualized if you want to. In fact, most of our clients prefer to deploy our solutions on VMs, and even a moderately sized VM with either 4 or 6 virtual CPU and 6 or 8 gigs of RAM can still manage 1,000, 1,500 devices. You step that up just a little bit and you can get yourself to 2,000, 2,500, 3,000 very, very quickly on a moderately sized virtual machine. So here we have just a basic table view of all of our devices in the network. A couple of different ways to view that. We can also view it as a panel view. So these panels have some ability for you to kind of define what gets shown. Apologies there. Now what I want to do is I want to take all of my devices and I can view them in a map. So very, very quickly, I want to be able to create a network map or a topological map from the list of devices that are being monitored by my system. So from a workflow standpoint, generally speaking, what you do is you use OpenAudit to find everything that's on your network, and then you use OP charts to be able to map that out and create dashboards that make sense to you and your team on a daily basis. So now this is just a quick view of all the devices. You can see with the color-coded backgrounds whether the devices are healthy, degraded, or offline for some reason, unreachable. I'm just going to pick one device and I'm going to right-click on it and hit Add Subnets. And what that's going to do is that's going to start wiring my devices together. All this information already exists. I'm just telling the system that I wanted to start putting things together for me. This grid layout's not working, so I'm going to pick a different one. I'm going to pick a concentric circle. And so I've got some very, very small icons here. And so we're just going to use the scroll wheel, zoom in a little bit, and then I'm going to start picking some additional devices and adding more subnets. And now you can see that I'm getting more and more devices are now logging in. I'm getting more subnets here. And I can continue to add more devices to this. But you'll note, as I continue to add more and more pieces to this, it's going to become busy. And I can choose different layouts. I can go to a COS. This will give me a little live piece here. I can do a cola. There we go. Now we've got some pieces breaking out. And so I can continue to play with this and break this down and add subnets. You'll also note that I can select things like add neighbors. So that's going to give me all my BGP neighbors. So that's going to start drawing dashed lines between devices, and all of these are live. And I can also go through here and I can start deleting pieces that I don't care about. So for example, there may be subnets here I don't want to see. There may be connectivities or relationships I don't care for, and I can break this out. Now this is a really complex view. There's a lot of devices going on here. And one of the early things that we said is that you want to take a very, very high level abstracted view about your network, something that is bigger and chunkier than this, and then work your way down. So let's start over again. Let's go back to the nodes view now that we know what this can do. And I'm just going to use the filter on the left. So down the left-hand side, this is a filter. So for example, I might want to just take a look at the Gold Coast office. There's only 12 devices there, so let's take a look at the Gold Coast office. Now that gives me 12 devices. A couple of them are unreachable, several are degraded. Now I'm just going to view that in the map. So whatever I have selected with my filter is what I can send over to my topology mapping. And again, I'm just going to right-click, subnets, right-click, add neighbors. So that's giving me a couple of BGP neighbors here. All right, there we go. So we've got some good connectivity here. We're kind of getting a feel for how things run together. I can get rid of pieces I don't want, so I don't really need that. And I don't need that piece either. Notice that the screen redraws for me. I can change that auto layout. There's all kinds of different pieces that I can do here as well, whether I want to do breadth first, circle, whatever. So you can play around with that, and then you can save this. So on the left-hand side, you can give this map a name. I can give it a description. I can give it a title. If I want to, I can apply a background image to this. I mentioned earlier the concept that you might have an existing Visio diagram, or you might have a background image just with your company logo on it. And you want that kind of a background watermarked image behind the scenes. So if anybody captures a copy of that, they know who owns this. Just a couple of thoughts. But let's take a look at what this might look like from kind of a little higher level maturity and polish. So I'm going to switch over. So this is actually two different maps in one. So I've created, on the right-hand side, I've created a topology map. And then on the left-hand side, I've actually created a geographic map. So the geographic map is based on Google Maps. I can zoom in, zoom out. A lot of stuff we can do with this. These icons are live. This one happens to represent just one piece of equipment. This one's a couple pieces of equipment. And I can drill into these data centers by clicking on their titles. Same thing over here. All of these are live as well, so I can drill into any of these, and I can drill down into the individual piece of equipment. Now, one of the other things I've also done is I've kind of created a mid-level diagram. So we talked about the concept of having a very high-level abstract, right? We've helped companies do implementations where their high-level abstract was actually a global map, and they would have individual icons for each major city where they had a presence. And that individual icon would actually represent a grouping or several pieces of equipment. It could be hundreds of pieces, thousands of pieces of equipment. So, for example, in the New York headquarters, or the London headquarters, or the Houston headquarters, or the San Diego headquarters. And then you could provide all of your link lines in between those with all of your speeds of your connectivity and all of your ISP information. But a mid-level might be more focused. And in this case, this mid-level happens to be just a single monitored service, or in this case, series of services that are grouped together. And again, this is something that you have to define for yourself. Some people may look at this and say, my mid-level needs to be a diagram of the core network at that location. So you might start with a global view or a view of the US and say, oh, I want to see the mid-level view of New York, and then end up at the kind of the core network for your New York LAN with all of your routers and all of your gateways within that location, how that works, and then be able to drill down into those various points into more equipment detail. Slightly different view. This one happens to be more application centric. So you'll still see a topological map along the top center, and again, still live. I can still get information about these individual pieces of equipment. I can drill down into these pieces of equipment if I want to. Down the right-hand side, I have specific monitored services for specific application. I have application tests, so I'm running synthetic transactions on my application, testing my application database for throughput. And then along the bottom, I have all of the circuits for my internet traffic for this application. So I'm keeping track of how well the traffic for that application is moving in and out of that circuit. Again, all of these are predicated on the concept that you're going to start at a very, very abstract level, right? Whether it's a topological map, whether it's a geographic map, depends on you, right? At a very high-end abstracted view of your overall topology, and then moving down into a middle layer. How you define that is up to you, how you define that middle layer. And then generally speaking, the most detailed layer is going to be something along the lines of either a very detailed application or performance view, all the way down into that kind of device by device level performance. So how well is this one individual device doing versus everything else that's within the value chain for my organization at that location. Just a couple last quick notes here. For those of you who are wondering, all of these icons that are here, you can apply your own custom labels to them. You can apply your own custom links to these. So when it comes to being able to do things like, again, documentation, how do I keep track of things? You can apply labels to all of your link lines. You know, what are your circuits? What are the speeds? Where do they connect to? What vendor provides that connection? All of that information can be provided here. All of that information is also available under various different views. So whether it's a view of the interfaces, a view of the business services, various views of monitored services as well. Up to you which pieces of the puzzle that you use, but it's all about being able to provide you with multiple sets of tools, and then allowing you, the user, to determine how and where do you want to apply those within your workflow, your business, in addressing your documentation and your diagramming needs. And again, one of the reasons that we go this route, I've worked extensively over the years with static diagrams of the network, and the challenge with those is the moment you're done with those, the moment you publish them out to the organization, they're already out of date, they're already old, and inevitably people leave, people forget where the original of those documentations are. By using a system like OP Charts or like Open Audit, by having your documentation live that everyone can see, you can back up, you can make a copy of, you can print out if necessary. But at the end of the day, this information is all live for us. So you can see what your organization is, what your topological structure of your network is, and whether it's a simple topology diagram with a dozen or so icons on it, or whether it's a very complex one with hundreds or even thousands that you pan and zoom and move around. It's really comes down to how it's being used and who's using it. So feel free to take a look. All of these products are available on Opmantic's website, www.opmantic.com. Go to the downloads page. You can get all of our products. They all come with, I think, a 20 device free license for all of them, so you can install them on your home network, put them in your lab network at work, run them up, try them, see how they work. We have a very detailed wiki to walk you through installation, configuration, and you're also welcome to email us here at contact@opmantic.com, ask us questions. We'll help you out, point you in the right direction, answer any of your questions. So that concludes our presentation at this point. So what I'm going to do is I'm going to go ahead and turn off recording, and then we can open the floor for any questions that might be out there.